Welcome, everybody, to Power Glove. This is our Senior Design 2 project, which takes data from a glove covered in different sensors and uses it to model a graphical hand in a Unity scene. On top of that, we use a trained machine learning algorithm to detect the state of the user's hand. Our neural network is able to determine whether the user is making one of the ASL signs for the numbers 0 to 9, or whether they are not making any of those signs. Here you can see a sort of game which can train you to get good at making the signs 0 through 9, but with a bit of more work it could be used to practice for maybe something like rock concerts once that is safe again. And then maybe if you wanted to move to Hawaii, you could also practice your shaka, as seen here. Getting into the hardware of things, we used flex sensors, which change resistance based on how much they are bent, to measure bending for both the fingers and thumb. To model finger spreading, we use Hall effect sensors and a neodymium magnet placed in between the fingers. Finally, to measure the wrist movement, we use an IMU that detects the motion of one of the Arduino Nanos placed on top of the hand. In order to process the data and fit all of these sensors, we use two different Arduino Nanos. One Arduino Nano Every and an Arduino Nano BLE33 Sense. The BLE33 Sense sends its data to the Arduino Every, and we package this data in order to serially communicate with a PC running our Unity software. We serialize this data into a JSON object, which organizes the data with labels so that we know which output is coming from which sensor. This data is then used to move our Unity hand model in a way that mirrors the user's movements, which gives you something like this. This is done through a combination of scaling, thresholds, averages, and various Unity functions. We use forward kinematics in order to model the user's hand in real time. Lastly, there is the machine learning algorithm, which takes the data from our physical glove and uses it through extensive training to determine the sign that the user is making. We first had to train our neural network using a Leap motion controller just to get it started identifying signs. Later we were able to transition into using sensor data to detect these digits. And with more work, this project could easily be used to detect different states of the hand. So, using this system, we could potentially add more American Sign Language signs, or any other signs for that matter. Another fun step could be gesture detection. That way, I could finally play rock, paper, scissors remotely, and prove, conclusively, that I am the best RPS player of all time. But in all seriousness, I think I speak for the whole team when I say that this project came together quite well, considering the circumstances of this semester. We were able to greatly surpass our goal of 60% for sign detection, coming in at around 90% usually. Thank you for watching our video, and have a nice day.